In this video, we will discuss a useful technique for sketching polar curves. So if we're given a curve in this form, r equals a function of theta, how do we go about sketching it? Well, much like a parametric equation, what we can do is make a table of values. So for a theta value, what is that corresponding value of r? Now, a way to kind of help us fill up this table is to first sketch a Cartesian representation of this. So if we sketch the Cartesian curve y equals 2 cosine x, so note this is not the polar curve we're looking for, it's just going to help us get there. So if we look at this curve from pi to pi, so we're thinking 2 cosine x, it's the cosine curve where we just adjust its height above and below the x-axis, i.e. its amplitude to be 2. So roughly speaking, it's going to look something like this, where we have 2 and minus 2. Furthermore, where it intersects the axes for the first time here would be pi over 2, and then 3 pi over 2. So let's think about some theta values. Some theta values, let's go 0, pi over 4, pi over 2, 3 pi over 4, pi, and we'll use that as a starting point. And each point that we come up with, we would like to sketch as a polar representation. So when theta is 0, r is 2 cosine of 0, which is 2. So in polar coordinates, if r is 2 and theta is 0, that would put us at this point here. So r is 2, theta is 0. When theta is pi over 4, we would have 2 cosine pi over 4, which is 2 over root 2, because cosine pi over 4 is root 2. So for pi over 4, roughly speaking, and you do not have to draw these dashed lines, it's just to help me out, we'll have 2 over root 2. So let's roughly say maybe right about here. So that would be 2 root 2 pi over 4 in polar coordinates. When theta is pi over 2, we see graphically r is going to be 0. So that would give us the point. So pi over 2 would correspond to this positive vertical axis, and then 0 for an r value puts you right at the origin. 3 pi over 4, we now see that looking at our graph, it's going to be the opposite of pi over 4, so minus 2 over root 2. So in terms of sketching this point, if we go 3 pi over 4, we would have this ray that we've drawn, but because it's a negative r value, you need to go in that opposite direction. So right about there would give us the point minus 2 root 2, 3 pi over 4. And when theta is equal to pi, our r value is going to be minus 2. And theta equals pi corresponds to the negative axes, but because our r value is negative, we end up back at this point where we started. So this is going to be minus 2 for the r value, theta being pi. Let's go one more point to kind of see what happens. So after pi, you might go to 5 pi over 4. Corresponding to theta equals 5 pi over 4, we would have 2 cosine 5 pi over 4. So also that minus 2 over root 2. Root 2, where previously that should have been a minus 2 over root 2. And similarly, that should have been a minus 2 over root 2 and 2 over root 2. And for this last point, 5 pi over 4 would correspond to the ray drawn here, but the negative r value means we go in that opposite direction, and we end up back at this point that we had previously. So minus 2 over square root 2, comma 5 pi over 4. And if you keep going around, you'll see that you just end up repeating the curve as you go from pi to 2 pi. So what we end up with is something that looks like this. It should be a circle. And it is a circle, and one could actually, much like one of our previous problems, convert this into its corresponding Cartesian equation. And hopefully this gives us a slightly cleaner looking version of this graph. So r equals 2 cosine theta is a circle of radius 1 centered on the x-axis at this point 1 comma 0. And this might make you wonder kind of in general, do we know what r equals a cosine theta will be? Or maybe r equals a sine theta as well. And it turns out that x equals a cosine theta is going to be a similar looking circle. So it opens up along this positive x-axis. And this point is going to be a comma 0. Similarly, for r equals a sine theta, we're going to also have a circle which ends up being radius a over 2, except now it opens up along the positive, formerly the positive y-axis. So it will look something like this, where in polar coordinates this point would be a comma pi over 2. So r equals a cosine theta, r equals a sine theta, both represent circles, and these are definitely equations that we would want to be familiar with as they do appear somewhat frequently. So let's use this technique to sketch another polar curve, r equals 2 plus cosine theta. So once again, we're going to want to start off by making a table of values, and we can really fill in this table of values conveniently by sketching the graph of r equals 2 plus cosine theta as a Cartesian, not polar curve. So if we think about sketching this from 0 to 2 pi, that would give us one period of the function. Putting the 2 with this, so if we think of this as being y equals 2 plus cosine of x, it's going to take the cosine curve, which normally oscillates between -1 and 1, and lift it 2 units upward. So what used to happen at 0 now happens at 2, and the curve is going to oscillate back and forth between 3 and 1. So roughly speaking, it'll look something like this, where this point would correspond to pi over 2, and this other point would correspond to 3 pi over 2. And let's just kind of look at these nice points to deal with. Theta being 0, pi over 2, pi, 3 pi over 2, 2 pi. And as we're sketching the curve, if we need any additional polar points, we'll find them. So let's put this in its polar form. So by inspection here, when theta is 0, our r value should be the output of this curve. So 3. When theta is pi over 2, we're at 2 for our r value. So theta varying from 0 to pi over 2 is telling us what's happening here in the first quadrant. So let's get this information down. So at 0, you're 3 units away from the origin. So we have the polar point 3 comma 0. And at pi over 2, you're 2 units away from the origin. So you have this polar point 2 comma pi over 2. And if you think about what's happening between 0 and pi over 2, that r value is changing from 3 to 2. So as we rotate around, that is, we increase our theta value, we go from 3 to 2. So roughly speaking, in this first quadrant, will look something like this. Let's move on to the second quadrant. When theta is pi, we see that r is going to be 1. So that would give us the point on our graph. R is 1, theta is pi. Between pi over 2 and pi, so as theta goes from pi over 2 to pi, your r value shrinks from 2 down to 1. So something like this. Now going on to 3 pi over 2. At 3 pi over 2, r is again 2. So we have the point 2 2 comma 3 pi over 2. And in that third quadrant, our R value is now increasing from 1 up to 2 as we rotate around. So it starts at 1, and as we rotate around, it increases to 2. And at theta equals 2 pi, you're back at an R value of 3. So we're really, making use of this Cartesian graph to help us get our values in the table to sketch our polar curve. So 3 comma 0 is actually the exact same point in polar coordinates as 3 comma 2 pi. So in the fourth quadrant, as we increase our theta value from 3 pi over 2 to 2 pi, our R value increases from 2 to 3. And we get a curve that roughly looks something like this. And let's look at a maybe cleaner form of this graph. And generally speaking, this is something which is called a limicon, which we will encounter more of in the future, but looking through some of the pictures provided in the textbook would certainly help recognize the various limicons we could encounter.